Hello and welcome to lesson 10.3. Today we're going to look at solving quadratics. So just to do a quick refresher, we're going to talk about what a quadratic equation is. A quadratic equation is written in standard form if we have ax squared plus bx plus c. Okay, now what we're going to do when we have to solve these is we're going to set them equal to 0. Okay, and standard form, if you remember, is when we have the highest degree listed first, followed by the next degree, or the next lower degree, and the next lower degree, all the way down until we get to a constant. So with quadratic equations, we can actually have either 2, 1, or no real solutions. Okay, you will get to the point in your math careers where you're going to talk about imaginary solutions, but for right now, when we're in this class, we're only worried about the real solutions. Solutions of a quadratic equation are also going to be considered or called the x-intercepts of the graph. Now, your x-intercepts can also be called roots or zeros. So sometimes a problem might tell you to solve a quadratic equation. It might tell you to find the x-intercepts, it might tell you to find the roots, or it might tell you to find the zeros, and this all means the exact same thing. So when we look at these three different graphs here, when you have a graph that has two solutions, notice we end up with two x-intercepts. Okay, so two solutions means that we have two x-intercepts. When we have one solution, the vertex of our parabola is sitting right on that x-axis. And then when we have no intercepts, all that means is that our graph is not going to cross the x-axis anywhere. So again, two solutions means we have two x-intercepts. One solution means that the vertex is sitting right on that x-axis, and no solution means that we have nothing that crosses our x-axis. So for example 1, we're going to solve our problem to find our x-intercepts. And to do that, what we're going to do is I'm going to take my 2x squared, subtract 98, and set it equal to 0. So this kind of starts out just like your standard algebra equation. I need to get my x terms by themselves, so I'm going to add 98 to both sides. This is going to give me 2x squared equals 98. Then I'm going to divide both sides by 2, and I'm left with x squared equals 49. And remember, when you undo a square, you're going to do that with a square root. So when you square root 49, you're left with x equals both a positive and a negative 7. So that tells me that I have an x-intercept at a positive 7 and a negative 7. So if I graph those, 7 is going to be kind of out here. And 7 will be kind of right here. So these are my x-intercepts. Now we can go ahead and find my vertex. And my vertex is going to be at the opposite of b over 2a. So when x equals the opposite of b, well, in this case, there is nothing, over 2 times 2. So this is just 0. So I have my x coordinate point is 0. When I plug a 0 in here, I'm left with a negative 98. So if I make each one of these tick marks on the y-axis 20, this is a negative 20, negative 40, 60, 80, 100. 98 is going to be just before that. And I now can graph my parabola by connecting my vertex points with my two x-intercepts. So just to reiterate how to solve for our x-intercepts, on this example, it says to solve t squared minus 25 equals 0. Again, I'm going to get the t value by itself, and I'm going to add 25 to both sides. So I end up with t squared equals 25. I need to undo the square by square rooting both sides, and t is going to equal plus or minus 5. These are my two x-intercepts. For example 3, we're told to solve 3n squared plus 12 equals 12. So the first thing I'm going to do is I'm going to subtract 12 from both sides, and that leaves us with 3n squared equals 0. We're going to divide both sides by 3, and we have n squared equals 0. And if I square root both sides to undo the squared, I have n equals 0. So now because I've only got one, this tells me that I only have one solution, to where in example 2 we had two solutions because we had the plus or minus possibility. For example 4, we're told to solve 2n squared plus 32 equals 0. So I'm going to subtract 32 from both sides. I'm left with 2n squared equals a negative 32. Divide both sides by 2, and now I have n squared equals a negative 16. I'm going to undo my square by square rooting, and right away I notice that I cannot take the square root of a negative number. So this tells me that I have no solution because I cannot take the square root of a negative number. So that would be a case where I have no x-intercepts. And for our last example, on example 5, it says a city is planning a circular duck pond for a new park. The depth of the pond will be 4 feet, and the volume will be 20,000 cubic feet. We have to find the radius of the pond to the nearest tenth of a foot. And they're giving us the equation that V equals pi r squared h, where V is the volume. Okay, so we can go ahead and plug that in right now. So we have 20,000 cubic feet. Pi is a constant. We know that our radius is going to be the unknown value, and we're told that the height will be 4 feet, so I'm going to multiply that by 4. So now, in order to solve for my r value, I do have to divide everything by 4 pi. I'm just going to combine these because these are my two constants. So if I divide both sides by 4 pi, these are going to cancel, and that's going to leave me with r squared. And 20,000 divided by 4 pi is 1,591.55. And because this is r squared, I do need to square root both sides. And when I square root both sides, I end up with the radius, or r, equaling 39.9 feet. I do not need to look at the negative answer because it does not make sense to have a negative radius. So this is my final answer. Please let me know if you have any questions. Otherwise, I will see you guys in class. Have a great day.